So when we're testing for non-reducing sugar, you always need to make sure that you carry out the reducing sugar test first so that you can eliminate whether or not the sample is actually a reducing sugar. You wouldn't know if you did the non-reducing sugar test first. So this is the result of testing two samples, A and B, with the reducing sugar test, and we saw that sample B gave us a negative result. It remained blue, indicating to us that sample B is not a reducing sugar. So if we take sample A away, we know that that's a reducing sugar because it turned orange. So we don't need to go any further with that sample. So sample B, then we need to continue to find out whether if it's actually a non-reducing sugar instead. So really important that we discard this sample and we now take a new sample of our solution B. So a fresh sample of B in our tube, and the first thing we need to do this time is add some hydrochloric acid. And we're going to heat the sample up again after adding our hydrochloric acid. Okay, so hydrochloric acid added to our solution. And we're placing it back into the water bath. And we place it back into the hot water bath for around about 2 to 3 minutes. So it's really important that this water is as hot as it can be, and so the acid starts to work. And we'll talk about what's happened and what that acid is actually doing to the sample in a sec. Okay, so 2 or 3 minutes has passed, and what we need to do now is remove our sample and we need to neutralise that acid. So we neutralise the acid with an alkaline, and we tend to use sodium hydrogen carbonate. But for your exam, it really doesn't matter if you can't remember that name. What's important is that you remember it's an alkaline and its purpose is to neutralise the hydrochloric acid. So we just add half a spatula full in there, and as you can see, as we add the alkaline, it starts to fizz up a bit. So the idea is that you add the alkaline until the solution doesn't fizz anymore, and you know that that has been neutralised. Okay. And then we finally add our Benedict's solution again. So if you remember, the Benedict's solution was a blue colour. So we add Benedict's again to our solution before reheating it. And again, remember, it's important to talk about the temperature. We heat it to above 60 degrees. So originally we added the acid, and you have to boil the sample with acid. So boil with acid, you heat with Benedict's. Boil with acid, heat with Benedict's. So we'll just leave that sample to develop for 2 to 3 minutes again with the Benedict's in our hot water bath. Okay, so about 10 minutes has passed now, and we can see that after that time, our sample B has now changed to that orange, nearly brick red colour. So this was our sample B after the reducing sugar test. It stayed blue, indicating that sample B was not a reducing sugar. But we took a fresh sample and we added a hydrochloric acid, and we boiled with hydrochloric acid. We then neutralised the hydrochloric acid using sodium hydrogen carbonate, which is an alkaline. And then we added our Benedict's solution again, and we placed our sample back into our hot water bath, and we heated the sample with the Benedict's. And on this second occasion, you can see that we have a positive result. The solutions turn from blue to orange. So this indicates that sample B was in fact a non-reducing sugar. And the non-reducing sugar that you need to remember for your exam is sucrose. So sample B must be sucrose. There are no other non-reducing sugars that we see. Now, this is a little bit of an extension, thinking about why we actually see this result. So initially, we had a negative result because there was no reducing sugar present. But if you think about what sucrose actually is, sucrose is a disaccharide, and sucrose is actually made up of the two monosaccharides, glucose plus fructose, joined by a glycosidic bond. Now, when we added the hydrochloric acid, the acid actually broke that glycosidic bond, releasing separate glucose and fructose monosaccharides, which are in fact both reducing sugars. So when we tested the sample with Benedict's solution for the second time, we were in fact getting a positive result because the reducing sugars had been released.